Okay, so this is 4-6 notes part 2. So in the first part we decided, or we looked at whether or not something was a function. So let's look at an example from part 1. And here's a set of ordered pairs. There's 4 ordered pairs there. Okay? And it's 4, 4.2, 1.5, so 4.2, comma 1.5. Let's see, 5, 2.2. 7, 4.8. And 2, 4.8. Okay? So we remember that we list the domain. So I want to tell domain, range, and if the relation is a function. So we do a mapping. We call the domain first. And the domain is listing out the inputs, or the x's. So it's 4.2, 5, 7, and 2. And then we look at the range. And the range is 1.5, 2.2, 4.8, and since 4.8 is twice, I'll only list it once. So that's the range. So 4.2 goes to 1.5. 5 goes to 2.2. 7 goes to 4.8. And 2 goes to 4.8. So that's the domain and the range. And now, is it a function? So if you remember from part 1 that a function is a relation in which each value in the domain is paired with exactly one value in the range. So is each part of the domain paired with exactly one element in the range? And the answer is yes. You see, 4.2 goes to 1, 5 goes to 1 element, 7 goes to 1 element, and 2 goes to 1 element. This one is a little different, but since each one of them go to only 1, it is a function. Even though 7 and 2 go to the same output, you can have 2 inputs go to the same output, but you cannot have 2 inputs going to different outputs. So that's the difference. So every x is different. Yes, it's a function. Okay? So another way to tell a function is from a graph. So from a graph, tell if it's a function, by using the vertical line test. Okay? By using the vertical line test. And so what that means is this. I'm going to graph something. This is the y-axis, and this is the x-axis. Okay? So here's my graph. I'm going to graph a function, or I'm going to graph a set of x and y's that look like this. All right? So I'm going to make this kind of curvy. Now, each one of these points along this line has an x and a y. Okay, so there's an xy here, there's an xy here, and so on. Now, there's something called the vertical line test. And a vertical line is up and down. And a vertical line test is if a vertical line touches the graph twice, if any vertical line touches the graph twice, the graph is not a function. So if a vert line touches graph 2 times, now it's not a function. No, not a function. So let's look at this graph and see if it passes the vertical line test. So I'm going to draw a vertical line. Does it touch? It only touches once. 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 So what that means is there's one x. Okay, there's all the x's are different for the y's. Okay? So yes, this one is a function. Yes, this graph is a function. All right, that's the vertical line test. Now let's do another example. Okay, so here's another example of the vertical line test. I'll draw y-axis here, and I'll draw an x-axis. Okay, and then I'll draw another graph. And this time I'll draw a graph like this. Okay, so let's apply the vertical line test. The vertical line test, vert line test. So if it touches twice, it's not a function. And in the first example, we saw it only touched it once. Now this example, look, if we touched it once right here and once right here, okay, so that's one x. You see this is the x value. It has 2 y's. So let's say x equals -1 right there. Okay, x equals -1. This point right here is -1, -2. And this point right up here is -1, 4. So this point and this point have 2 different outputs for the same x. So this graph, this orange graph, is not a function. No, not a function. So that's the vertical line test. Okay, that's what you have to remember, excuse me, to apply the vertical line test, all right, to a graph. So the vertical line test will tell you from a graph if it's a function, if the graph is a function. In the first example, there weren't any vertical lines that touched the graph twice, so every x had a different y. But in this one, this x of -1 had 2 different y's, and you can see it touched the graph twice, once here and once here. So that graph, this orange graph, was not a function. All right, this is the y-axis, this is the x-axis. Okay, so that's the vertical line test. The very last piece of this section is function notation. Okay, function notation looks like this. It's a lowercase f parentheses x, right? This is f of x, so f of x. Okay, that's what it means, f of x, f of x, f of x. X is the input. F of x, which is really y, which is y, is the output. Now remember, your inputs are the range. Okay, all inputs equal the range. okay? And remember, all the outputs, oh no, I'm sorry, that was bad, my fault. It's not the range, it's the domain. I was thinking ahead. All right, all the inputs are called the domain. That's the x's. All the outputs are the range. All right, that was not good, but we fixed it. All outputs are called a range. Okay, so f of x is function notation. That's what it means. F of x means f of x. So for example, okay, for example, f of x equals 2x minus 7. Okay, and I want to find f of 3. So this is f of 3. So the input is 3, all right, but we don't know the output yet, so we got to put it in. So f of 3 equals 2 times 3 minus 7, and that's negative 1. So the pair is 3, which was the x, and negative 1, which was the y. Okay, this was the input-output. All right, the input was 3. All right, and the output was negative 1. Okay? So f of x is the function notation. Okay. Example 2. This is the last one here. If f of x equals negative 5x plus 2, we want to find f of negative 1, f of 0, f of 1, and f of 2. And then we want to list domain, range. Okay? So here's how we do it. We're going to find f of negative 1, and we're going to find f of 0, we're going to find f of 1, and we're going to find f of 2. F of negative 1 is negative 5 times negative 1 plus 2. F of 0 is negative 5 times 0 plus 2. F of 1 is negative 5 times 1 plus 2. And f of 2 is negative 5 times 2 plus 2. So this is 7, this is 2, this is negative 3, and this is negative 7. Or negative 8. Okay? So we substituted those values in. All right? Negative 1, 0, 1, and 2. We substituted them in for x. The input. Okay, here they are again. And we substituted them in. And we got out a set of outputs. And those were all the outputs. And that's the range. So the domain is negative 1, 0, 1, 2. And the range is 7, 2, negative 3, negative 8. So domain, range, and that's it. So that's how you do it, okay? F of x is the function notation. Substituting the values in, we listed the domain and range based on the inputs and outputs. That's 4-6, part 2.